In this example, we want to write this expression as a single logarithm, so just one logarithm. We have 3 logarithms in this example, so we want to condense it into one using the properties of logs. So I'm going to begin with this coefficient out in front, this 1/2 that's getting multiplied by the first logarithm. And I can bring that and write it as an exponent on the argument. So that can become log base 2 of z to the 1/2 power for starters. As you become more comfortable with the properties, you may feel comfortable using all of them at one time, but I'm going to show each step in this example. Now, looking at these 3 logarithms, it's important to realize that they are all log base 2, and that's why we're allowed to use the properties of logs to condense them into a single log. So next we will take the first 2, and because they are being added, we'll condense them into a single logarithm, and that means we are going to multiply the arguments. So z to the 1/2 will get multiplied by w. Again, the arguments are the z to the 1/2 and the w. It's what you're taking the log of. So when you have a sum, when you have addition, and you condense those together, there is going to be multiplication here in the new argument. Then we still have minus log base 2 of x plus 3. And then our final property of logs will be the subtraction. So we will condense these 2 logs together, and subtraction becomes division. So the arguments are going to get divided. So this will be z to the 1/2 times w divided by the quantity x plus 3. And that will be our single logarithm. Now I want to mention you do have an alternative way of writing the z to the 1/2. If you wanted to write that as a square root, you certainly could. So this is the square root of z times w, all divided by x plus 3. And that would be equivalent and equally good.